Let me introduce IBA to you as soon as that's going to work. Is it not working? There it is. Okay. All right. We're Institute for Biblical Authority. We exist to communicate the Bible as trustworthy and authoritative, beginning its first word in Genesis 1:1, all the way and extending through to the last word in Revelation 22:21. And so I have the first and last words of the Bible up there. So would somebody read that first one for me, the Hebrew one? Well, what does it translate? You know that. Some of you do. In the beginning, right? 3 words. And it's, let's see, right there, Barashit. All right? Barashit. Now, so it's kind of like a lamb, ba, ra, kind of cheering, and then sheet. All right? So we're going to put it together. Let's do it. We're going to learn Hebrew today. Barashit. Okay, now remember, you got to get a little south of the border and roll that R, all right? Barashit. Not bad. All right, last word in the Bible is ponton. We got somebody who can read it. What does ponton mean? All. Most people say the last word in the Bible is amen. Well, actually, that's added. Just to end this text, this is the last word, all. May the grace of the Lord Jesus Christ be with you all. Great, isn't that? That's actually a great ending to the scripture. So that's what we are all about. All right, this little video is called, this little event, I'm going to show you aerial photography of what Michael Lord has discovered. I give Michael the credit all the time I do this because he's kind of put up with me kind of tagging along with him once in a while, and we try to do some film stuff, and I never have been able to get it figured out how to edit that properly. But anyways, he taught me a lot of things. And then I took a drone, and I've taken a drone out and filmed some of these things, and oh my. So we're going to start with this little clip. I actually made this, so hang on. Here we go. Get a chance to read those? That last one's quite profane in your face, isn't it? That's pretty profane. We've been lied to about Noah's Ark. But even better, that's the wrong word. Even worse is this group, Biologos, because logos, or logos, depending on how you pronounce the Greek word, is word. So this is biology and God's word. And it's a Christian organization that is trying to teach us how to reinterpret the Bible according to science. And this is what they say from their website. I checked it a while back. It's still there. The scientific and historical evidence is now clear. This is a Christian organization. And we've seen this from colleges too. There's never been a global flood that covered the entire earth. And I like to say my drone says otherwise. We like to take issue with that. So let's start with, and we've kind of been reiterating this, but I want to pound this in because you got to get this. What's the issue here? The issue is deep time. We've talked about that. Mike's going to talk more about that. And the young earth. The young earth. So let's apply that. What is the issue here? If we take that bracket and that's a hypothetical section of layers of the Grand Canyon. According to deep time, that might be 3 million years of deposition that formed that. A young earth, looking at the same data, would maybe say 1 week of flood surge from Noah's Ark. Total different way of looking at things. Here's the point. If you believe the Bible is trustworthy and the flood of Noah was an actual event, then these layers originated in the flood of Noah. All right? So we have to rethink, because some of you are going, whoa. Now, if you saw this earlier today or yesterday, you just have to be quiet. But here's our case in point. How many years did it take to cut this canyon? Some of you are smiling now. You're thinking, yeah, because you've heard the answer. The answer is 3 days. This was cut in 3 days by the Lake Missoula flood. And that's what we want to define. Now, I took this picture. This is in Washington State, out of I want to say Lewistown, but it's Lewiston. Yeah, get that right, Clarkston area. And I took this picture here, then I turned this way for 90 degrees, and there is Palouse Falls. Beautiful, isn't that? Beautiful falls. And I took this picture, and then one day I was referring back to it, and I looked and I saw that whole thing. I said, well, what is that? That was left behind by the Lake Missoula flood. So let's take a closer look. And I looked at that thing, and I said, look at those little projections on the top. They're like little fingers. And this thing isn't small. It's probably as wide as this stage, and as long, yeah, about the length of this whole room here. And it's made out of basalt, which is volcanic rock. But remember, there's cracks there. And so we get spring rains and snow, and we get ice, and it's working to take that apart. So how many millions of years do you think that would last? That wouldn't last millions of years. And so keep that in mind. And now let's talk about our country, Lake Missoula flood. This was really the riddle was starting to unravel under this guy, J. Harlan Bretz. And he was a school teacher in Seattle, Washington, high school. And he really loved geology, taught you a lot about geology, and he was studying how things formed out in Washington State. And somewhere in the teens of the 1910, 1920s, he received some of the first topographical maps of Washington State. And here's one of those maps. And if you can read topographical maps, you can see that this part is like North Dakota on the right side. But when you go over the left side, all of a sudden it drops down into just a mass of cliffs and things. And he said, wow, what happened here? So he started taking his students out over the top of the Cascades and would go down into central Washington and study this. Now, this is the early 1900s in Washington State. A lot of the roads don't exist that exist today. Paved roads don't exist much. If they did at all, I don't know. But it was not an easy trip. They would walk 20 to 30 miles. I read some of the stories about some of the hikes he took these students on. It's like, oh my goodness. He discovered some things. Here's one of them. He discovered a 3-mile wide waterfall. See that? In a desert with no water. Okay, but he knew that it was there because there was this deep plunge pools where the water came ripping over the top and cut that in. You can see a white speck. If you go straight down from the middle arrow, you'll see a white speck. That's a boat there, so you get size perspective of this waterfall. And then as I looked at this, I saw that little island out there kind of away from the rim. And I went down and looked at it. It's hundreds of feet high. Notice it's somewhat flat on top, has sheer cliffs. And then it looks like that's a talus fall where the rocks have fallen down. They call it talus when it falls off the top. But actually, that's the formation. And then there's just some rocks that have fallen down that have come on top of that. Well, anyways, J. Harlan Bretz began to write up his findings. And he realized that a massive flood came through Washington State. In the 1900s now, geology had gotten rid of Noah's flood. And so this didn't fly well. And so he was called by the Geological Society of Washington, D.C., to come and present his findings. How do you think that went? It didn't go well. And it was interesting is he came there to show everybody what he found because none of these people had been out there. So he started showing and made his presentation, and he said later in his memoirs, he said it was like standing before the elders who were going to correct the protege. And he walked away realizing, well, maybe I did get this wrong. So he went out and he went out and went out and he kept finding, no, this is a massive evidence of a flood. Well, at the meeting in 1927, they convened it to deal with Bretz, and what they said was, what Bretz proposed was not allowed. Not allowed. We've gotten rid of the flood. This was too much like, this is their words as far as I can tell. Now, at this convention in Washington, there was a guy from a place that you might have heard of named Missoula, Montana. He was a geologist right here. And he supposedly leans over to somebody next to him and said, I think I know where Brett's water came from. You see, Brett didn't know where the water came from. He knew it came from Spokane somewhere, but he didn't know where and why. He just knew he was just doing the geology and saying some water came through here. Now, it was interesting. Pardee didn't raise his hand and say, hey, let me help you out. He saw what was going on, and he kept quiet for quite a while. But you see, this is what I think Pardee saw. And this is an old cell phone picture. I was at the corner of Brooks there coming out of the mall, and the snow was just right. So on Mount Sentinel, you can see those lake lines going up the mountain. And here's another one, and I took our tour out to this spot. This is Mount Jumbo, just boom, boom, and you can see, let's see if we can get there. Well, you can see the lake lines going up. Now, what happened is the Clark Fork of the Columbia got blocked. So a dam basically formed by ice during the Ice Age. Which Ice Age did I mention? The Ice Age. Michael will help us out on that. The Ice Age, the one Ice Age. And it blocked off the Clark Fork of the Columbia, and so there was no drainage from the Bitterroot Valley, no drainage from the Clark Fork, the Blackfoot. It all just kept going higher and higher and higher and higher. And so every year, the ice would make a mark on the lake, and then wind would blow and cut marks on there on the ambient wind. And so we see the evidence. So this is what Pardee saw, but there was more. But before we get to that, I'm going to take you to the Sea of Cortez. That's that little armpit sea with the Baja California there and mainland Mexico. One of my sons lives in L.A., and he works in the film business, and it drives him crazy as a Montana boy to do that, so he rented a place down in Mexico, kind of where that arrow is pointing, and on the Baja side. And so we went down one winter, getting tired of Montana snow, and went down one winter, and he said, Dad, when you get down here, this is the strangest place. He said, during high tide, you'd walk up to the shore, and it's like a normal high tide. There's the beach, there's the water coming in. Low tide, it goes for 1 mile to 2 miles out there until you get to the water again, and it's just flat as can be, full of sand and dirt. And here it is. That's what you see when you get to low tide. I told this to a friend of mine who lived down there. He said, yeah, the first time I went down there with my boat, everybody was laughing because it was beached for half the day until the tide came back in. I didn't know, So that's what it looks like. Look at those water ripples. That's formed like you see those water ripples in a stream. It's formed as the water's going back out. So if you go through and you tear those all up, which you can, we did, we walked through it, it'll all be gone and remade the next time the water goes out. That's what water does. Now, those are only about this big. All right, well, Pardee saw another thing, and so I had to go out there and take a look at it and see what is. And I actually read this in Michael's book about Camas Prairie water ripples. Some of you were on my trip yesterday. How many of you were there? All right, so these people have seen this firsthand. Isn't that something? I mean, it is really something. And we got here, and you get out of the truck, and it's pretty anticlimactic at the overview. It's just like, there it is. Oh, there's some trees out there. I wanted you to remember those. But you see the water ripples there? I don't. But they're right there. Can you see them? Those are 45 feet high. At the highest place. Here's now the drone flying up them. And you can see the trees way up on the top. That's where we were. And this is from the water ripping off as the Lake Missoula Dam burst, the ice dam burst at the Idaho-Montana line. And now the water is just ripping off this mountainside and left these 45-foot-high water ripples. And you can see the direction of the water flow. Up there, you see the white arrow? That's flowing a different direction than this is, and you can tell it'll flow perpendicular to the water ripples. There's one way, and there's another way flying there. I'll show you a still picture of it in a second here. There it is. So you can see two different directions of water flow by the ripples. You see how you can figure that out? That'll be important later. To be part of our test. By the way, there's a test following. All right. So what happened? Well, during the Ice Age, a sheet of ice came down through Sandpoint, Idaho, dug out Lake Pend Oreille, and blocked up the Clark Fork of the Columbia right at the Montana-Idaho line. 2,000 feet high, 23 miles long. Massive sheet of ice. And it slammed into the mountains, so it just blocked it up, and the lake just got higher and higher every year. And so Pardee, he had seen the water ripples, and he'd seen the lake lines. So he knew where the water came from. He just wasn't talking. He eventually will. The two will get together. Well, that amount of pressure, and I suspect now the Ice Age is probably starting to wane down because of the conditions are starting to normalize. The ocean's cooling down. And so it eventually exploded and shot water across Washington State in a massive tidal wave, 800 feet high as it's coming out of that canyon. We can't even fathom 800-foot-high tidal wave. And then it spreads out across Washington State, leaving us the channeled scablands. And that's what we're seeing here. So there's Sandpoint. There's the Idaho line, kind of on the far side of the circle. That'd be on that side, I guess. And there's Palouse Falls, by the way. You saw the falls. And we're going to talk about this spot, the Wallua Gap. If you look at Wallua Gap, you can see right here the water backed up because it couldn't get through the Wallua Gap fast enough. And that Wallua Gap is 1.2 miles wide. So it couldn't get through there fast enough. So this is a massive amount of water. It went down the Columbia Gorge, cutting it out, and then some of it backed up the Willamette Valley south of Portland all the way to Eugene. And there were floating on icebergs were some of Montana rocks that got left in the fields, and they called it erratics. And then it eventually went out through Astoria there out to the sea. So we can see that there. All right. So I bought this drone, and I thought, let's go out and see what's out there. So here is right by Spokane, and actually Sprague, just out of Spokane. Notice the water channels. You can see them, right? You can see the water channels going through there. These are about 70 feet high, this particular ones. And notice that these things are flat-topped. You see those water channels coming into play. They have a sheer cliff. And then they have the shoulder that comes down at from 60 degrees to about 30 degrees in angle. There's a water channel, tried to break through, but most of the water ended up going around this little erosional remnant. We called it an erosional remnant because it was left behind, and went out that way. And you see that flat yellow area? That's where the interstate flow goes. They didn't build it right through this area. It was too much work. So that is what the scablands look. Look out in the distance. You see it. And you see those dimensions. That one's about 30 degrees at the shoulder. That is, what does that look like to you? Looks like little buttes, didn't it? Now here's another, this is just a little farther away. And see one of those little buttes? So this is just kind of left behind. But you're also going to see, you can visualize water channels all over the place. You can see them now from the air. You can't really see them from the ground. But coming into view is something really important. This is a characteristic of the scablands called the pothole lakes. Notice the this is rounded lake, and the banks are kind of rounded like a router bit went around it, a 45-degree router bit. You see that? And notice how it kind of goes around and circles around that. This is common. What in the world caused that? This is what we see from a massive flood, okay? And there's the scablands all torn apart. And you can, and sheep country. It's not worth a whole lot of anything else. That is why I was flying here once, and then all of a sudden there was helicopters all over the place because the armed services uses that to do practices in, because it's not worth a lot in other ways. All right, to use Michael Ord's term, geomorphological observations, the bumps that are left behind for the rest of us. So, notice what we see. We see these butte-like shapes, flat tops, 90-degree cliffs, 30 to 60-degree shoulders. We see water channels that are going through there. We also see some of them that are pencil-shaped that point the direction of the water flow. Another thing we discover are these pothole lakes, and they're round, oval, different shapes of roundness, and you can see that it kind of varies a little bit. And they have this bank that varies in angular degree, but it looks like a router bit went around that. And we know now pretty certainly that these are caused by turbulent whirlpools. You know those whirlpools, you ever seen on the rivers where the water eddies back and then you see these little whirlpools in the river? Only these are massive. These are tear you apart type of whirlpools. Okay, so we're going to go out near George, Washington. I just love the name of that town. And this is Frenchman Coulee, 1 mile off the interstate, but nobody sees it. It's flat bottom, sheer cliffs, 600 feet down, a 45-degree angle bank. This is hard basalt rock. Look at that little cathedral thumb thing sticking up out of there. That would be an erosional remnant left behind also. Look at those walls. That's different flows of lava that were cut completely in 3 days by the power of that water. There's an erosional remnant left behind, and I know why that's there. I thought about this for years. It's because of the hanging canyon. Now, what's the hanging canyon? Take a look. This canyon was flowing that way when the larger flow got channelized and flew that way and cut that off, leaving it hanging. It never eroded all the way down. You got that? That's important. You see it? You can see the way that was made. That was a hanging canyon. Main flow came down, or flow came that way and then got cut off. And that's what I think that changing the water left that little cathedral thing there. I don't know. I saw that guy out there. I took a picture of him. Anyways, he's flying a drone. Okay, what do we see? We see flat bottom stream beds with 90-degree cliffs to 45-degree shoulders. That's one of the observations. Isn't it interesting? It's flat bottom. Now, is that perfectly flat? No. In fact, you can see some water channels through there, but it's reasonably flat. And then it goes up to those cliffs and shoulders. Let's go out a little farther. This is near Quincy. I just love the colors on this picture. The lake just looked so beautiful that day. They did build a little dam to make this impoundment here. Otherwise, those other lakes are natural. And this was all cut in that 3-day period from the Lake Missoula flood. And coming into the foreground, I slowed it down now. You see what looks like a heart-shaped lake. Do you see it? Right here. Notice the angle of the bank. You see that? And this turbulent whirlpool was spinning, and then it spun out and cut channels out. So it had a drainage so the lake doesn't fill all the way up. As we get out there, now we're into a waterfall, massive waterfall. In fact, the water is carrying way out here into that lake, and it's coming back up and deposited this gravel bar that is about 70 to 90 feet high, has a 45-degree bank as well. Isn't that interesting? Look what's coming into view now. What is that? You know it now. It's an erosional remnant. Everything else got eroded away, and that got left behind. A water channel tries to cut through right there. And then there's whole nother channel over on the other side of this. And by the way, look at the dimensions. And look at the top of that. Semi-flat, and it's the same level as the countryside behind it. Coming into view now is all the farm countryside. Remember how that topographical map looked? This is that area, and look how flat it is. And then there's these little lakes. Notice the 45-degree angle banks all along here. These banks are a 45-degree angle. That's interesting. This is a big waterfall came over here. All this turbulence gets kind of stirred up, and all this gravel is left behind. It's kind of amazing. And then you see it's perfectly flat. I've driven that area for years and never found this until one day I just happened to be looking on my maps, and I went, why are the roads going around? And then I looked, there's little lakes down there. I want to go check this out. Oh, man. I walked out to this cliff. I didn't know this was here. And I went, oh, my goodness, this is 600 feet. You see the bird? We're 800 feet above that bird. So I flew that one evening. That's an interesting story. I had to walk in because it was fall, and then the sun was setting, and I had to cross all these cliffs, and I suddenly realized, get your tail out of here, Kevin, before it gets dark. I didn't bring a flashlight or anything. So, amazing country caused by the Lake Missoula flood. All right, you might have heard Michael Ord speak of planation surfaces. Well, there you are. That's that farmland above. But also, look at, you have a planation surface down below as well. So at this one, we have the box is a long erosional remnant pointing the direction of the flow. Do you see that? It's a peninsula erosional remnant. It was left behind. The water washed everything else away. Number two, that's deep plunge pool with water making that lake below the rim. And then we have a flat bottom creek bed that follows out, and that's the arrow 3. Very important, we have this vortex lake that's, they would call it a calc in geological terms, this vortex-formed lake, and then the exit channel in blue. You can see that the vortex spun around, exited, cutting away, giving it an exit of the water. Now, I told you about the Walua Gap. Here's what it is. That's how big it is. That's 1.2 miles across. The water flow was so much it had to leave that behind. It made a lake behind it. There, you see that little thumb? There it is. That's not a little thumb. The Native Americans called this the Two Sisters. There are evidently two coyotes in their view. Fairly level elevation-wise, but this got cut like stovepipe. Do you see that? They're rounded like stovepipe, and it's on a base, and then it goes at a 45-degree angle, sheer downward. I believe this is formed by turbulent whirlpools as well, because this is a side channel cutting around. I'm not certain about that. That's just my hypothesis. You ever heard that word before? Hypothesis. So that's pretty cool. That's a tower. I would call it a tower on a hill, so to speak, or on a cone. I would call it a cone-shaped remnant. All right, so here you go. What we have is we have towers and cones, and I suspect they're caused by erosional, by a turbulent whirlpool going around that, but it could have been some other way the water's channeling. Oh, and there's your drone pilot right there, so you can get an idea of size. This is a big area. All right, so Mike Ord's taught me a lot, and he taught me what causes these. And we think about as this flood released like a dam from Montana, it's spreading out and planing the surfaces down flat, giving us that flat farmland. You know, you take some boards like this that have been rough cut, and the old ways you did it that way to make them flat, right? Today we stick them in these little electric planers, and they come on out nice and flat. But notice all the chips there. In our analogy, that would be all the rocks that Michael was talking about that got spun around and are chewing things up. And so that's where we can see how all of that is made. So the planation surfaces are from the sheet flow phase. When that water's spreading even all the way across the state, planing everything down, and then the water starts to lower. And so when it lowers, it's going to channelize because there's not as much flow to cover everything. It starts to channelize, but there's a lot of water. And so now it's planing that down to the next level down. By the way, I see this all over North Dakota, in Montana, Wyoming. I see these same creek bottoms. And they're flat bottom, and there's a little creek that goes down the bottom of it. All right, what about the flat top erosional remnants? Now we start to understand. Can you put it together how buttes are formed? The whole butte, everything around the butte that's now down here was all up here, and it was all planed down evenly. The water starts lowering, it goes around the butte and leaves that flat top, and the buttes often have this tapered edge as the water is lowering, going down. So the channelized phase leaves that behind. Pothole lakes, we now know they're caused by turbulent whirlpools. Now, Michael Ord got this slide from Tass Walker, and I got it from him. And that's, we see that the flood went up. In this case, it came out like a deluge. And then it just goes down, 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 down. So when we think about the flood of Noah, why that first part Mike made very clear is the destruction phase. When everything's getting torn apart and all the sedimentary layers are being laid down. Surges are destroying everything. So when we look at that, the first 40 to 60 days, everything's being destroyed. And then after that, the surges are laying down rock layers. This is the best I can figure this out. Maybe I can get it corrected from Mike, but it's close to this. that we're seeing those layers laid down during that destructive phase. Now, the retreating phase, that's when we're starting to see it playing down. And Mike made it clear that almost half of the height was washed out and makes up the continental shelf now. And so it's being planed down. Do we have any evidence of this? We see during the sheet flow phase how it can make these very flat areas. And here I mentioned the Davis Buttes in Dickinson, North Dakota, where I grew up. There's one of those. Notice how flat that is. And then it kind of cones downward. And so that was all during the channelized phase that it starts to leave the buttes behind. And so in the channelized phase, this picture is in the Lake Missoula flood. This was all formed by the Lake Missoula flood. Notice where they built the road. They built it down in the bottom where it's flat. The river, the water made it nice and flat for us. All right? So the water volume drops and it begins to cut channels and then drills them out. All right. So that's all fine and dandy. Now, let's go outside of the Clark Fork drainage. Let's go on the other side of the Continental Divide and see what we see out there. We're going to see some planation surfaces. But this one is not far from Michael Ord's house. This is the Madison River Valley, right near the Buffalo Jump State Park. Okay, look how flat that is. Now, instead of dropping off like a cliff, it looks like water was pouring off of here in kind of off the top, and it cut little channels down. And we see that too. I didn't see that in the Lake Missoula flood, but we see it here. How else can you explain that in an area where there isn't much water flow going that way? There's probably some, but not a lot. Then we get down to the Madison River bottom. Is that flat? That's pretty flat, actually. Good farmland. And then there is a butte on top. That's one of those quartzite-topped rocks, buttes that Mike mentioned. And there again, we look back at the Madison River, and look how flat that is above it. That has been planed down. Then the water drops, channelizes, and planes it down again. And so we get very good evidence of massive water flow. And as Michael Ord said, this is not happening today. These aren't being formed. Now, I went over to the other side, and actually Michael Ord's standing right here when I filmed this, and that's one of those quartzite-topped erosional remnants, or buttes, if you will, on the other side of the Madison River Valley. And so I just flew, and those are all quartzite, rounded quartzite, or a lot of it is, on top, and I think he said it was like 75 feet thick there. There's where we were filming earlier, and that's the Madison River, bottom, below, and you can see it kind of has some rougher edges on the edge of it. So the Madison River Valley, we see a planation surface with a semi-flat riverbed below. Do we see this anywhere else? Anybody know where this is? This has got a great name. This is Chugwater Creek, Wyoming. Chugwater Creek. Now, look at this. Look at what you're seeing now already. Do you see the cliffs? Do you see the flat tops? Do you see the shoulders coming down? What about that bottomland? And then I saw this. This is interesting because this is where you make mistakes. I first thought those were water ripples because I'd seen water ripples, but I don't think so. I think those were actually those fingers that we're going to see. They're coming out, and then some of the water washed it off, leaving that as an erosional remnant. Question. Did the creek cut that creek bottom, or did the creek bottom cut the creek? Make the creek. In other words, the creek just followed the creek bottom that was made by Noah's flood. You see that? Because it's too wide for that creek to cut it. It's too wide. And this is the area by it. How did that form in this dry country? Look, this is dry country. This is spring or late spring. Early summer, and it's very green, but that place is dry. And then look above it. It's a planation surface for 35 miles till you hit almost to Nebraska. And it's just flat as a bone up there, and then it drops down on the other side as well. So we see some flat bottom creek beds with steep cliffs, very much like the Lake Missoula flood. And we see a planation surface above the cliffs that goes for miles. Now I'm going to take you to the Beartooth Mountains. How many been to the Beartooth? Most of you have. That's good. There's the Beartooth Highway going up the side of that. to 10,000 feet. And then there's Rock Creek down below. And what do you see now on the top? It's flat, isn't it? No, it's not perfectly flat, but it's really remarkably flat for the top of a mountain. I found that interesting, so I had to fly that thing. I'd come out on a backpack trip after I'd flown into Lake Missoula, and I said, look at this. So I pulled out the drone, and then you see water channels coming off of that, but more like we saw in the Madison River area, not sheer cliffs here. And so we see this area that has, it's not perfectly flat, but it's an amazing flat top of a mountain at 10,000 feet. And so we see a planation surface there, just like we saw in these places. All right? And then erosional remnants. Here, how many have been to this place? Isn't that is like the weirdest thing when you drive up to that. What's interesting about this is how much this has aged in my lifetime. When I first went there, and it actually got younger, because when I first went there, that was 22 million years old. And now it's only 2 million years old. It's amazing how much that thing's got a fountain of youth. We got to figure out how. Notice the top of it. Do you see it's flat? This is a volcano that came up. Now, let's put in a way of thinking of Noah's flood. The sediments are still pretty soft. Mountains are rising up, so magma's active. It pushes up through the silt, and then it cools, but then it gets cut off as water's rushing down. It cools, and then it becomes a rock in the middle of the stream, and it gets left behind. And by the way, at the base of that, there's all sorts of rubble, a rock that's breaking off actively. That's why they know it can't be that old, because it's going to erode away rapidly. All right, Highway 200, heading over from Lincoln, Montana. We see this butte complex. This is Crown Butte. Wait until we get up closer. This is a sill butte, and this is where the magma came up and then went under between the layers and cooled that way. Notice this water channel here, and this is facing towards the Rocky Mountains somewhat. There's a water channel there, and then it's on the top of the butte. From a distance, you would say it was flat, but look at it now. It's got water channels. You see that? But the water channels are still pretty wide when they hit the edge of the butte. It's like they continued on out into nowhere land, and it's like they got cut off. Do you see that? It's like that was longer and it got cut off. So how did those water channels form? That's our question. How did that happen? Now, what bothered me about this whole thing is that they kind of project out into the air, but they're pointing back towards the Rocky Mountains. And the water, if this is from Noah's flood, the water's going the other way. I'll show you what I mean here, seeing they project. So I started thinking about that, and I realized, wait a minute. I wonder if that rock was like a rock in the middle of a stream of a river. And when you get rock in the middle of a stream of the river, what's the water do? It comes back around because it's got to fill in that space. The rock is preventing it, the water's going around, and then it comes back and it eddies back. Just like we see here, this is an eddy right by my house in an irrigation ditch. Notice how the rocks, or the tennis balls I'm throwing in, are going backwards on an eddy. That's what an eddy is. See, the water's coming out fast, and then it expands, just like it was a rock in the stream. And so I thought about this, and I realized, water coming off the Rockies is eddying back and flowing that way. A little farther away is Cascade Butte. The city of Cascade is right back behind that arrow. But what are you seeing by that arrow? Do you see the water channels? But they go nowhere. They form on the top of this thing. There's water channels there. You want to see them from the side? They continued way out. This is the bottom end of a hanging canyon. You see, water was flowing this way, and then a channel came through and cut it off, leaving it hanging right there. Very interesting. By the way, hanging canyons are diagnostic of floods. It's a diagnostic. It's something you know it was a flood if it caused it. Okay, back to the Beartooths. Aren't the Beartooths beautiful? I mean, it's just like a gorgeous place. And by the way, I think on this day, I just barely got my drone back because a big storm came in right from here. But, you see some beautiful things from a drone that you don't get to see when you're hiking this. but it is just magnificent country. And I often wonder what those crossings are, if that's some formation or if that's been done by glaciers or what it was, or water. I'm not sure. But look at how they got now we talk about planation surfaces. That's why they're called the bear tooths, or at least one theory, the flat top like teeth sticking up there. Now, this is Beartooth Butte, and we have to take a look at this because this thing is real interesting. From the air, what do we see? We see water going around it. Do you see that little point? It's erosional remnant. All of the Beartooth is solid granite, except Beartooth Butte. It's full of sedimentary rock on top of the granite at 10,000 feet. And it's full of fossils. Full of fossils. You can see the water parted around it, leaving this behind. You see that kind of cup shape of the butte. Look at the size of this thing. And those cliffs are full of fossils in sedimentary rock on top of the granites at 10,000 feet. And I flew my drone into the wilderness, just so you know I did. And you're saying, oh, wait a minute. You can't fly a drone in the wilderness. No, you can't. But you can fly a drone from outside the wilderness over the wilderness. So just cleared that up in case you were wondering. And notice the iron levels, but also look real close at that iron area and you see a little finger thing sticking up. Do you see it? Right there. See that? How many millions of years do you think that lasts? See the point? You're starting to get eyes that are starting to ask questions that aren't normally asked. And so we're told this is millions of years ago that this formed, but I'm going to tell you this is from Noah's flood, and everything else got washed away, and this got left behind. This is an erosional remnant. And it's the only sedimentary rock in that particular area right there. And it's just astonishing to look at. It's fairly flat on top at the very peak that's left. You can see that. So there you go. They're somewhat flat on the very top of that. That's what it looks like. And you can see the water just came and went like that. You can see that. So at Beartooth Buttes, we have an erosional remnant. This is strong evidence of water rushing off the rising Beartooth rains. Now, this is the Beartooths at 10,000 feet. Where did the water come from? I mean, this is a massive water erosion leaving behind a fossil-containing sedimentary rock at 10,000 feet. Where did the water come from? Michael showed us from the Bible. The mountains rose and the valleys sank down. Basically, the mountains are coming up, the ocean bottoms, floors are sinking, and the water's rushing off, and that is exactly how God gave us these dry land after the flood. All right, I'm going to take you out to Hurricane, Utah. Not hurricane, spelled like that, but the locals tell us it's hurricane. So let's get it right, all right? Hurricane. So this is Hurricane Mesa, also called Monkey Butte. And I'm flying up on the ridge of this. I'm way down in the bottom there. And this is a track where they tested jet airplane injection seats. And it's called Monkey Buttes because they didn't put men in them, they put monkeys in them. And they shot them off that butte to see how they'd survive. So that's the true history of Monkey Butte, or Hurricane Mesa. Look behind it now. There's another level of mesas above that. And they're flat. And look how flat that is. That's a planation surface. And then you see erosion channels. You see the steep cliff, then the 45-degree angle. What do you see in here? Water's dropping, water's dropping, water's dropping, water's dropping as the flood is abating. You have evidence of that. You can't see that from anywhere except from the drone level. You could walk out there, but who's going to go up there? Why would you go there? It's kind of no man's land of the desert. Get bit by a rattlesnake or something. But look at those levels. You can see the water dropping, and it left this evidence of the water dropping as it's going down. It's kind of amazing what you can see from a drone. And then you can see water channels in a very deserty environment. All this water torn up countryside. So we have evidence of water levels dropping during a massive flood event. All right, so now we're going to go to Moab, Utah. There's a city of Moab. How many been there? Yeah, a lot of you have. And there's these cliffs, they're about 600 feet, 700 feet above it. And I thought, well, I got a drone, let's look what's above it. And so I'm on the other side of these, and I flew up there, and there's Moab, the city, and I'm going to fly up on the top there. By the way, that's where I'm camping and flying from, right there on the Colorado River. And look what I see. Do you see those water channels left behind, pointing right directly towards the La Salle Mountains? Pointing right directly towards them. And then I looked on Google Earth again, and I could see where those channels went, and they kind of turn as they go. But I also went farther back, and the Bajo Mountains, there's channels coming from that, and they merge, and then they turn. You can see the water coming off of the mountains. And so I went out to the Needles Overlook. Okay, there's the fins where I was. Here's the Needles Overlook. Oh, this is so fun to go out there with a drone. It is so much fun. And you look at this, and we're told millions of years made this. But look, there's the Abajo Mountains, and now we're down much lower, and there's fins again pointing towards the Abajo Mountains. So we see as those went up, water's coming down through here, flooding through, and leaving us water channels that we can identify, showing the direction of the water flow. Water fins, I like to call them. So these water fins give strong evidence of directional water flows from the rising mountains. Now, let's go to this. This is the farthest eastern portion of the Rocky Mountains, which is the Black Hills, the farthest eastern portion of the Rocky Mountains. Do you see them there? That's that green speck, that green blob there. What's that white stuff? Badlands of South Dakota. Now, I grew up in North Dakota, so I know Badlands, but our Badlands are simply the Little Missouri River breaklands or canyon land. These South Dakota ones are weirdo. They are strange. How many been there? That is like surreal, that place. And notice their location. And so there we are. We take a closer look at the Badlands. Here's a drone shot I took of it. Let's take a little tour of that. Now look at that. That is like the weirdest place in the world. I mean, it's flat bottom, and there's this mud, like somebody built castles on top of the mud. It's just like the strangest place I've ever seen. And this year, I think it was July, but it had rained and rained and rained, so it looked like a little golf courses down there. It was really kind of cool. Normally, this is as yellow as all get out, so God gave us a good contrast. But look how flat the bottom is. Then you have these castles, and look at that. There's a little green. There's a tee-off spot there to go out to that green there, a big, difficult spot. I don't like golf, but this could get me playing. And you look at this, and you see the water channels coming off, but this is flat on top. Then it goes down another level, and it gets flat, and then that gets washed away. This is from flood. This is flood stuff. This is clearly flood stuff. And by the way, I can't fly into the national park, so I'm on the edge of the national park, which is a mile up the road. Just clarifying that. So in case you want to make a phone call. Here we go. That's what it looks like. And as we go, you can look at the area around it. It's coming up. But look at that ridge we go down, and look at how the water's channeling off. And you go, that was a lot of rain to make all those channels, or it was something else. And look how flat it is in the bottomland. Okay, so let's talk about some water ripples. Now, you see the Badlands of South Dakota? What's below it? What is that? Do you see them? Does that look like water ripples? What do they call that? By the way, that covers a third of the state of Nebraska. What is it? Sand hills of Nebraska. Between my freshman and sophomore year, I went out and worked on a ranch out there. Oh my, talk about isolated. But those sand hills are a couple of miles across. These are not giant water ripples like we have. These are monster water ripples or something. We're told they're made by wind blowing the sand in, but nobody knows where it came from. But I looked at it, and what do I see? I see an angle of flow that way. Oh, that turns a little bit, and that turns that way. And what's behind it? The Black Hills. Do you see that? The water is flowing around the Black Hills and coming back at it. See the water ripples there? That's from Google Earth. That's from Google Earth. There's water ripples there from Google Earth, and there's water ripples from the Sea of Cortez. So here's my hypothesis, is that the water coming off the Rockies is hitting the Black Hills. And that's a rock in the stream, and the water's got to come around. Now, when you hit an eddy, does the water speed up or slow down? Slows down. And if you're carrying a lot of supersaturated material, what's going to happen to it? It's going to drop it. All right? And so the lighter material would be where it gets the slowest, which would be close to the Black Hills. And so it's dropping all the sediment that was on top of the Black Hills. It's cutting that off. It comes around, drops it, and then the heavier stuff gets dropped sooner as it's coming around through Nebraska and abruptly ends after that. And the sandhills end. They just end. And so we can see the water, and the ripples give us a picture of that. By the way, we're told, scientists have studied ripples, and they've studied sand that's wind-blown. And sand, anybody done the motorcycles or RVs or whatever, UVs, what's the word I'm thinking of? ATVs, there we go, on sand dunes. And what's the big danger? Because it drops off like 30 degrees or more after the wind carries it over. And so they're great fun to come up, as long as nobody else is coming the other way, and that's what happens. 30 degrees. But if they're waterborne, they're 25 degrees or less. The steepest angle is 25 degrees on the sandhills in Nebraska. They're water-formed, not wind-formed. The evidence is strong for that. All right, my favorite, potholes. This is my favorite. Take you out to Utah. How's my time? I got a minute or two. All right. So this is Big Mesa right out of Arches, right out of Arches. And so I flew over this and looked down. What are you seeing now? Do you see the pothole lakes? Do you see it? And you can even see where it comes in and comes out, comes in and comes out, and then forms these little lakes. You see the 45 to 60 degree angle of the spinning whirlpool cutting this on top. I don't know. And this is only on the edge. It's only on the edges. It's not in the interior of the butte or the mesa. It's just on the edges of it that you find this, where you would have water turning back and causing whirlpools. Look at how many of them are there. You see them? And you can even see where that water went through there, was spinning around, and it made an exit channel. This was a phenomenal find. This is 700 feet up to the top of this sucker. This is way up there. And I had to fly across a ladies' track meet that was running around down below, and flew up there and took pictures of this. And I just was not expecting to find that up there. All right, now let's look at cones and towers. This is Chimney Rock in Nebraska. And I've renamed this, by the way, and I've renamed it my Clock Tower of Nebraska. And notice the dimensions, 45-degree base with this tower on top. Look carefully at the top. Do you see the cracks? This is a sandstone. It's cracking apart. The clock is ticking. How many millions of years do you think that would stay up there? It can't be. So I named it the Clock Tower. That's my name of the formation. I want to show you something, a picture of this from 150 years ago. It was 30 feet higher in that picture. And the reason why is because it's breaking apart. So how many millions of years has this been here? This is only thousands of years at best. Okay, one more place in Utah I got to show you, and then we'll have our final test. Look at the layers. I included this because you're going to look at those layers. It's just gorgeous, but also you can see uplifts and happening and new layers getting cut off and all that's going on. And what do you see as we come up on top? Do you see those like cone shapes? Look at them again. It's a whole field of cones on the edge of a peninsula or erosional remnant. It's on the edge where there'd be turbulence going around, circulating as water is coming off. There'd be some circulating back, forming this massive cone field. Now, my thought was this is caused by turbulent water, but I wasn't sure until this flight. And on this flight, it confirmed it as I was looking at these cones that are just almost perfectly shaped. Of course, not perfect, but it's really quite amazing what you see there. And I'm thinking to myself, how did these form? Even if I think of the flood, I'm still struggling until I flew this. You see it now? That confirms this is by turbulent whirlpools. There is a pothole lake, if you will. That this whole area is full of pothole lake cuts. You can see the cuts in the rock. All through here, you see that angular cut with then these are on top. See an angular cut there, and then you have some cones up on top. I am convinced that is by the whirlpools on this peninsula as the water is cutting back and coming around, eddying back, and makes this cut across the top of this that is on the edge of Zion National Park, but not in Zion National Park. All right? I'm going to have to, let's see, I got to show you a little bit of Sentinel Butte. What do I have here? Well, our time is almost out. Do I have enough here? Yes, I'm going to show you this. So that was Sentinel Butte. That's where I used to hunt. And I always tell people the deer and I had a game up there. I'd fling arrows down at them. They'd jump out of the way, and then I'd go down and pick them up, and we repeat that every week. So it was a lot of fun. Nobody got hurt, so it was safe. Anyways, so Google Earth, I want you to see Sentinel Butte. There's Interstate 94 heading towards Dickinson, heading back to Glendive, Montana. And there's the town of Sentinel Butte. It's in a valley, and there's the butte itself. Look at this. This is a cone field, and I'll show you that in a minute. And they're pointing the direction of the water flow. And the water is flowing through there, made a big valley. And then on the other end, there's Sentinel Butte again, and there's a smaller cone field on the other side. All right? So let's go fly it. And right there, that's what it looks like. When I grew up, I saw those things right along the interstate, and I always wondered, how did that get there? I mean, wow, that's astonishing. Well, I think that was, see, where the big flow's going this way, and you have this little erosional remnant, and you're getting whirlpools. There's the butte, and you can see that, and this is the smaller side, and we'll skip that because time is short. So, final test. We're over time, but we got to do the final test. Are you ready? All right? See what you've learned. First off, I'm going to take you to arches. Now, see if you see what nobody else sees. What are you seeing? Now you have a clue how the arch formed. Turbulent whirlpool, and it's leaving the arch behind. It's nicking it. It's nicking it as it's spinning. And it didn't build a lake because it built an exit channel. You see how the size of the people? Everybody's walking around this. I've talked to geologists, creationist geologists, who've been there, and they say, I didn't see that before. I didn't see that before. Look what's straight ahead. That'll go out of the way in a second. What do you see straight? Now, there's the arch. There's that whirlpool area. And by the way, where that girl is standing, you don't go another 5 feet that way. It drops 700 feet. And it'll just take you right over the edge if you get too close. So everybody's being careful right there. And then you turn this way and you see this. But notice that there's a cone associated with a whirlpool right there. Turn. What do you see coming up right here? Cones. And in fact, I turned back to take a look. And by the way, there's the cliff that you will fall off of. Even with this family that's going to be right here, I'm like, grab that girl, because if she goes 5 feet that way, she's dead. I mean, it's just like scary right there. That's called the delicate arch. And here's what it looks like at the distance. See all the cones? Can you see the arch? Can you pick it out? There. That's the delicate arch, and all those cones are on top. There's the whirlpool lake, and there's the cone field. This is by turbulent water. Now, the final test. Are you ready? All right, you guys did pretty well because you picked that out. All right, here we go. You've seen this before, right? Monument Valley. Now look at it. Now what do you see? What do you see there? Cliff with the shoulder. What do you see in there? Flat bottom. There. Erosional remnant, flat top. Look at that little guy. Okay, so we'll come back to that. See, that's all the same as Lake Missoula, Flat Bottom Creek. There's an erosional remnant, just like those little buttes. But I love this one the best. Let's move in on it. You see that little spicule up there? How many millions of years would that last? Does that remind you of that from the Lake Missoula flood? Now, here's the question I have about this whole thing as we look at those guys. Where, if that's true, that all that dirt's washing off, where did it go? Where is it? Sea of Cortez. That's what you walk out on where I was at. In fact, if you go out right up in the armpit of the Sea of Cortez in low tide, you can walk if you had time, you could walk all the way across 30, 40, 50 miles, whatever it is. It's all full of sand and dirt that came from there. BioLogos says the scientific and historical evidence is now clear. There's never been a global flood that covered the entire earth. Oh, I don't think so. Thank you very much.